In example 4, the question states that in example 2, we discussed a simple electric circuit with resistance 12 ohms, inductance 4 henries, and a battery with voltage 60 volts. If the switch is closed when t is equal to 0, we modeled the current I at time t by the initial value problem. The equation was di divided by dt is equal to 15 minus 3I, where we have I of 0, which is equal to 0. What we want to do is we want to estimate the current in the circuit half a second after the switch is closed. So we're going to use Euler's method with ft, I is equal to 15 minus 3I, where the initial value of time t is equal to 0, and the initial current is equal to 0, and the step size h is equal to 0.1 second. So the formula that we have, we're just going to replace our y variable and our x variable with I being the current replacing y, and the value of x is now going to become t because that'll be the value of time. So we're going to use this formula here to then fill in the information. So we have I of 1, which is equal to 0, which is the current, plus 0.1 times 15 minus 3 times 0, which is equal to 1.5. And then plugging in 1.5 now, and for I subscript 1, to solve for I subscript 2 is plus 0.1. 15 minus 3 times 1.5 is equal to 2.55. Following the same procedure, now 2.55 becomes I subscript 2 to find I subscript 3 plus 0.1 times 15 minus 3 times 2.55 is equal to 3.285. And we're going to follow the same procedure. We're going to plug in 3.285 to get I subscript 4 to be 3.7995. And then finally, we're going to end up with I subscript 5, plugging in the value of I subscript 4, and then using order of operations to get 4.15965. So that would represent the current after 0.5 seconds. And that means that I of 0.5 is approximately 4.16 amperes.